Okay, so now we have the vertex of a parabola. And if I'm giving this equation, you can also find it without putting it in standard form, which is the beauty part about this. So you don't have to waste your time putting the equations in standard form unless you want to put them in standard form. If I gave you the problem this way, you could actually also find the vertex of the parabola. And the formula for that is negative b over 2a. I'll help you find the vertex. So to find the whole vertex point, you need to take this answer and plug it in for x to find out what your y point happens to be as well.
I caught you a delicious bass.
So find the vertex of 2x squared minus 6x plus 4. Now, you could put it into standard form, and you could sit there and say the opposite of h and k and get your vertex point. Or, instead of doing that, you could just use the formula that I said of negative b over 2a. So, first of all, I look at this, I notice that this is positive, meaning the parabola is going up. Like that, which means the point I'm finding is going to be a minimum point because it goes to infinity up high. So the formula is negative b over 2a. This is b, so it's going to be negative 6 over 2 times 2 because that's your a. So negative times negative is positive 6. 2 times 2 is 4, which simplifies to 3 over 2. That's your x value. So I know my x point. But now I need to take that 3 over 2 and plug it in for x. And this is where having a graphing calculator again would come into play, because if you plugged it in just like I have it written here, 2 parentheses 3 divided by 2 and parentheses squared minus 6 parentheses 3 divided by 2 and parentheses plus 4 and pressed enter all in one shot, you'd have your y value right away. If you don't, you're going to have to do some math by hand to figure this all out. So that would be a 9/4. So take the 2 through to get 18/4, and that would be minus an 18/2 plus 4. And then you're going to have to find common denominators. So to find a common denominator for this, I'd multiply both the top and the bottom by 2. This one I need to multiply the top and the bottom by 4. So you end up with 18/4 minus 36/4 plus 16/4. Add the tops all together to get negative 2 over 4, which simplifies to negative 1/2. So your whole point is 3 over 2 and negative 1/2. And there is your point. So that's your vertex point, which I told you would be your minimum for that graph.
Do not go in there.
So find the vertex point for this one. Once again, it's negative b over 2a, so it's negative 12 divided by 2 times negative 2. So negative is positive 12. 2 times negative 2 is negative 4. 12 divided by negative 4 is negative 3. Once again, keep in mind, because there's a negative out in front, the graph goes like this. It goes down, meaning we're actually finding a maximum point for this graph. So that's my x value. To find my y value, I need to plug in that negative 3. So once again, I plug in that negative 3. I get a 9 there. It's negative 18, positive 36, negative 13, which equals 5. So your max for this problem is negative 3.5. And like I told you, is that the max or min, and it is the max because this is negative, meaning your graph is going down like this. So up top, right there, is your point of interest.
For God's sakes, Jim, I'm a doctor, not a fool, man.
Example 8. A long rectangular sheet of metal 12 inches wide is to be made into a rain gutter by turning up 2 sides. So you have a flat sheet of metal, you're just going to bend up the 2 sides. So they are perpendicular to the sheet. How many inches should be turned up to give the gutter its greatest capacity? Greatest capacity. That's your key word there. Greatest. Another word for greatest is maximum. So to find your maximum value is what we're looking for here. So I don't know how high to bend these up, so I'm calling them both x. But I do know that they're both x because either side I'm bending up exactly the same amount. That's why I know that they're both x. I know the whole thing is 12 inches long. So that's how I get this middle, because whatever's left over will be 12 minus those 2 x's. So to find the area because we want to know what it holds. The capacity is the area that we're talking about. The area, because we're basically going to end up forming some kind of quadrilateral, some kind of rectangle. It's length times the width. So just going to multiply those two together. So it's x times 12 minus 2x. So I take that and go through. So I got 12x minus 2x squared. And all I did there was rewrite it into our quadratic form. So in this problem, what's my b? My b, because remember the formula, it's negative b over 2a. My b happens to be 12. So it's negative b over 2a, so it's negative 12 over 2 times negative 2, which is negative 12 over negative 4, which is a positive 3. So to find the greatest capacity, we need to find the vertex point. And we did so. We found 3. Now I could plug that in, but we just want to know what x is. So that means I would have to fold up x 3 on each side. That's what that problem was saying. A projectile is fired vertically upward. This is where max is really used in physics often. This formula here you will use in physics all the time, and it'll make your job so much easier. It says a projectile is fired vertically upward from a height of 600 feet above the ground. So basically, firing a rocket, it's going up, and eventually whatever comes up must come down. So you're making a parabola shape with anything that's fired or thrown in the air. So it's going to be reaching some kind of maximum point, and that's what you're going to try to find here. What was the highest point that it went? So its height is above ground after t seconds, and there's the formula. So the formula for that projectile being thrown up is given to you right there. So we determine a reasonable viewing rectangle that includes all those. So what I'm saying is when you go and plug that in on your graphing calculator, you're not going to be able to see it. So you might have to zoom out to figure out what that is. And then estimate when the height of the projectile is 5,000 feet above ground. That's B. So to estimate when the height is 5,000 feet above ground, I want to know when the height's 5,000 feet. So I plug the 5,000 in there. That's it. So to solve a quadratic, I move that over to make it 0. And I'm going to solve using the quadratic formula. If you don't have it in on your calculators, that's negative b over 2a, or negative b plus or minus the square root of b squared minus 4ac over 2a, for those of you that don't remember. But just to save some time here, you plug it in on your calculator, the negative b plus or minus the square root of b squared minus 4ac over 2a, and you end up getting 6.26 and 43.9 seconds. Well, when is it a height of 5,000? Why am I getting two answers? The reason why is it's going up. What we're saying is about 6 seconds in, it's 5,000 feet above the ground. But it's still going higher and higher and higher, and then it starts to come back down. And as it's coming back down, about 44 seconds is when it hits 5,000 feet again and comes back down. That's what we're saying. So it does make sense that there are two positive answers, that it will be at 5,000 feet. When will the projectile be more than that? It'll be more than 5,000 feet when it's between those two times. That's when, because when it's up at about 6, then it's still going to keep going higher and higher and higher, and then it'll come back down until it gets to about 44 seconds. So in between those two time frames is when the graph will be higher than 5,000 feet. And how long is the projectile in the air for? We want to know how long is the whole thing in the air for. The reason why I put 0 there is what's the final height that it'll be at? It'll be at 0. Its very final height. It'll come up and it'll be at 0 feet. You wanted to know when it was at 5,000 feet, so we plugged a 5,000 in. Now I want to know when it's going to be at 0. So that's why I plugged a 0 in there. And we go and solve that using the quadratic formula, the negative b plus or minus the square root of b squared minus 4ac over 2a. When you plug that in, you end up getting 50.92 seconds. So it's in the air for almost 51 seconds, this projectile. There are your answers. So there's your homework. If you have any other questions or concerns, just feel free to email me or let me know, and I will talk with you later.